Welcome to Learners Prep. In this session, we'll solve problems on trains. So this is the first session in this topic. First of all, let us see the basics of this concept of trains. Relative speed. So we have already seen relative speed in the time, speed and distance. If two trains are moving in the same direction at the speeds x meters per second and y meters per second respectively, and x is greater than y, then their relative speed is x minus y meters per second. So that is when the trains are moving in the same direction, the difference of the speeds is the relative speed. Similarly, if two trains are moving in the opposite direction at the speeds x meters per second and y meters per second respectively, then their relative speed is x plus y meters per second. The sum of the speeds is the relative speed when the trains are moving in the opposite direction. If two trains of lengths A and B are running in opposite direction with speeds s1 meters per second and s2 meters per second, then time taken by the two trains to cross each other can be calculated by A plus B, that is a sum of the lengths of both the trains divided by sum of the speeds s1 plus s2. So since the trains are moving in the opposite direction, the relative speed is sum of the speeds. Similarly, if the trains are moving in the same direction, so the time taken will be sum of the lengths of the trains divided by relative speed is the difference of the speeds, A plus B by S1 minus S2. Next, time taken by a train of length d meters to cross a signal post or a standing man is time taken by the train to cross d meters is d by speed of the train. So distance it has to pass through the length of the train to cross the standing man or the signal post. And time taken by the train of length d1 meters to pass a stationary object of length d2 is the time taken by the train to cover d1 plus d2. So stationary object can be a platform or any bridge or anything. So it should have some length. So to cross that object, so the distance to be covered is length of that object plus length of the train divided by speed of the train. Similarly, time taken by a train of length d1 meters to pass a moving object of length d2 is determined by considering the relative speed between the moving objects. So, sum of the lengths of the objects divided by relative speed is because both of them are moving in the same direction or opposite direction. So distances are sum of the distances we have to cover, and relative speed we have to divide with relative speed. That gives the time taken to cross that moving object. So now let us see practice questions based on these concepts. A freight train is 360 meters long and travels at a constant speed of 72 kilometers per hour. How much time will it take to completely pass a signal post standing beside the railway track? So here signal post is a standing object here. Speed of the train is given as 72 kilometers per hour and length of the train is given as 360 meters. So we have to convert speed from kilometers per hour to meters per second. So we have seen in the previous concepts to convert kilometers per hour to meters per second. What we have to do? We have to multiply with 5 by 18. So if you multiply with 5 by 18, the speed is converted from kilometer per hour to meter per second. So if you simplify this, 18 fours 72. So that gives us 4 fives 20. So this is meters per second. This is the speed of the train. So what is the length of the train here? So this is the speed and length. So length is 360 meters. So time will be length of the train. So this is the length of the train. That much distance the train has to go forward to cross the signal post divided by 20. So this is 18 times. 20 18s 360. So that is 18 seconds is the answer. This is the time taken for the train to cross the signal post. B is the correct answer. Now we move on to question number 2. A train travels at 54 kilometers per hour and overtakes a person walking at 9 kilometers per hour in the same direction. The train completely passes the person in 20 seconds. If the same train crosses a platform in 44 seconds, what are the lengths of the train and the platform? So here length of the train is given here 54 kilometers per hour. Speed of the train is given as 54 kilometers per hour, and it is overtaking a person walking in the same direction at a speed of 9 kilometers per hour. So the train and the person, both of them are traveling in the same direction. So their relative speed we have to find out. So relative speed will be difference of the speeds. So relative speed is difference of the speeds of train and the person. 54 minus 9, that is 45. 45 kilometers per hour. This is a relative speed. So if you convert this into meters per second, this should be multiplied by 5 by 18. So if you multiply with 5 by 18, if you simplify this, 9 twos, 9 fives. So what is remaining here? 5 into 5, 25 by 2, that is 12.5 meters per second, or 25 by 2. Anyway, you can continue. Now the train completely passes a person in 20 seconds. So what is the distance to be covered for the train? Whatever is the length of the train, that much distance it has to cover. So relative speed is 12.5 meters per second. Completely passes the person in 25. If the same train crosses a platform in 44 seconds, what are the lengths of the train and platform? So here we don't know what is the length of the train here. So let us assume length of the train as L. So length of the train as L1. Let us assume as L1. So it is given here length of the train as L1 in the question. So length of the train is L1 and relative speed is 12.5. So 12.5 is the relative speed. So this is the distance to be covered L1 and relative speed is 12.5. So how long will it take for the train to cross the person? 20 seconds. So 20 seconds. So the time taken is 20 seconds. So now L1 is equals to 12.5 multiplied by 20. So how much it is? L1 is 125 into 2, 250 meters. So length of the train is 250 meters. And now the same train crosses the platform in 44 seconds. So length of the platform we don't know. We should assume it as L2. So for the train to cross the platform, it should cross the distance. It should cover the distance length of the train plus length of the platform. L2. So how long will it take? It will take 44 seconds to cross the platform. Sorry, relative speed, we should take the length of the train here. Since the platform is not moving, this time is 44 seconds. Length of the speed of the train we have to consider in the denominator. Speed of the train is 54 kilometers per hour. So 54 kilometers per hour, we have to convert this into meters per second, multiply it with 5 by 18. So 18 ones, 18 threes. So what's remaining here? 3 fives, 15. So this is 15 meters per second. This is the speed of the train. So divide this with speed of the train. So length of the platform plus length of the train. If you divide with the speed of the train, you will get the time taken to cross. So according to the question, 44 seconds is the time taken to cross. So now simplify this, you will get the length of the platform. So by cross multiplication, 250 plus L2 is equals to 15 fours 60, 6 carry, 15 fours 60 again, plus 6 is 66. So L2 is equals to 660 minus 250. So how much is it? By subtraction, 0, 1, 4. 410 meters. So this is the length of the platform. So L1, length of the train, 250 meters. 410 meters is the length of the platform. So what is the correct answer? The option A is the correct answer here. Now question number 3. A train moving at a uniform speed crosses a 90-meter long platform in 12 seconds and a 150-meter long platform in 16 seconds. Determine the length of the train and its speed. Length of the train is not given. We have to assume it as L. Length of the train, we will assume it as L. So to cross the platform of length 90 meters. So it should cross the length of the train and also the length of the platform. And the speed of the train is not given here. We should assume the speed of the train as S. Speed of the train is S. And what is the time taken here? 12 seconds. 12 seconds is the time taken here. Similarly, it crosses a platform of 150 meters long. L plus 150. We don't know the speed of the train. And how long will it take? 16 seconds. 16 seconds it will take. Now, L plus 90 divided by 12 is equals to S. L plus 150 divided by 16 is equals to S. So speed in both the cases is L plus 9 by 12 in the first case, and in the second case L plus 150 by 16. So in both the cases speed of the train is same. So let us equate it. L plus 9 by 12 is equals to L plus 150 by 16. So if you simplify, 4 threes, 4 fours. Now let us cross multiply. 4L plus 36 is equals to 3L plus 750. Sorry, 450. 15 threes, 45. So 450. 4L, so this is, 90, L plus 90. I missed 1 0 here. L plus 90. So that is 360 here. So 4L minus 3L is L. 450 minus 360 is 90. So length of the train is 90 meters. Sorry. Yeah, length of the train is 90 meters. 90 meters is length of the train. Length of the train is 90 meters. Now we have to find out speed of the train. Speed of the train. So let us simplify the value of L in any one of these two equations above. So in the first one, let us substitute 90 plus 90. L value is 90 plus 90 divided by 12 is equals to S. So this is 180 by 12. 180 by 12. This is a speed, meters per second. So this is meters per second. So but the answers are given in kilometers per hour. So to convert meters per second into kilometers per hour, so what we have to do? We have to multiply with 18 by 5. So meters per second, we have to convert into kilometers per hour, multiply with 18 by 5. So if you simplify this, 12 ones, 12 fives, and 5 threes. So what is remaining? 3 into 18, 54 kilometers per hour. This is the speed of the train. Length of the train is 90 meters. Speed of the train is 54 kilometers per hour. So the correct answer is option A is the correct answer. Now let us see question number 4. A train was scheduled to reach station B at 4:40 p.m. Due to a temporary speed restriction, it traveled at only 80% of its usual speed and reached the station at 5:15 p.m. At what time did the train depart from station A? So here let us assume the normal speed of the train as 100. So normal speed let us assume as 100. Normal speed as 100. Then reduced speed or decreased speed is 80% of it. So that is 80. Let us find out ratio of speeds. Ratio of speeds. What is the ratio of speeds? 100 is to 80, which is 5 is to 4. 25's 24's. So we have discussed in the previous questions ratio of time. Ratio of time is the inverse ratio. That is 4 is to 5. So 4 parts is the time taken with normal speed and 5 parts is the time taken with reduced speed. So what is the difference here? So difference of timings. According to the ratio, it is 5 minus 4, 1 unit or 1 part is the difference of speeds. So according to the question, what is the time difference? So the scheduled time is 4:40, but it is reaching station B at 5:15. So 5:15 minus 4:40. What is the time difference? 5:15 minus 4:40 is 4:40 to 5, 20 minutes plus 15. Total 35 minutes. 35 minutes is the time difference. So according to the ratio, it is 1 part. So 1 part is equivalent to 35 minutes. So what is our question? Our question is we should find out the time of traveling. So at normal time, it will take 4 parts. Normal time is 4 parts and time with the decreased speed is 5 parts. So normal time is 4 parts, right? Let us find out 4 parts. So 4 parts is 35 into 4. which is equals to 100 and 4 5 20, 140 minutes. 140 minutes is 2 hours 20 minutes. 2 hours is 120 minutes plus additional 20 minutes. 2 hours 20 minutes. So the train was traveling at normal speed and reaching at station B 4:40 p.m. So we have found out time taken for with the normal speed. So from 4:40 we have to subtract 220. 4:40 p.m. minus 2 hours 20 minutes. 2 hours 20 minutes. So if you subtract, you'll get 2:20 p.m. So the train might have started at 2:20 p.m. So because we are considering the time taken with normal speed, so we have to consider the time of reaching at the normal speed. So time of reaching with normal speed is 4:40. So from that we have to subtract 2 hours 20 minutes. So if we found out 5 parts, we could have subtracted it from what was the time of reaching 5:15. So if we found out 5 parts here instead of 4 parts, we could have subtracted it from 5:15. So but here we found out the time taken with normal speed. So we subtracted it from 4:40. So the correct answer is option C is the correct answer. Question number 5. A cyclist is moving along a railway track at a speed of 6 kilometers per hour. A train 120 meters long is traveling in the same direction at 51 kilometers per hour. At a certain instant, the cyclist is 180 meters ahead of the front of the train. How much time will the train take to completely pass the cyclist? So here the person as well as the train both are moving in the same direction. Since they are moving in the same direction, we have to find out their relative speed by subtracting the speeds. So what is the speed of the train here? 51 kilometers per hour. Relative speed. Relative speed is difference of the speeds. Relative speed is 51 kilometers per hour is speed of the train and cyclist is 6 kilometers per hour. So the difference is 45 kilometers per hour. 45 kilometers per hour. This is the relative speed. Since the remaining distances are given in meters, we have to convert this relative speed into meters per second. So convert this into meters per second by multiplying with 5 by 18. Simplify this. 9 twos, 9 fives. What is remaining? 25 by 2 or 12.5 meters per second. This is the relative speed. So for the train to cross the cyclist, it should go forward by a distance of 120 meters because already there is a distance of 180 meters. The cyclist is 180 meters ahead. So it should cross that distance and also the length of the train. So length of the train is 120 meters. So to cross the cyclist, the train has to cover distance to be covered is already existing distance 180 meters between the train and the cyclist and also length of the train. Length of the train is 120 meters. So if you add this, you will get 300 meters. So this is the distance to be covered. And this you have to divide with the relative speed. 300 divided by 12.5. Since both of them are moving in the same direction, relative speed is the difference. So by dividing this, you will get the time taken for the train to pass the cyclist. So we have a decimal here. So to avoid the decimal, multiply both numerator and denominator by 2. So this is 600. This is 12.5 times 2 is 25. Now you can simplify easily, or you could multiply with 4 also. 25 2s 50, 25 4s 100, 24. So the time taken is 24 seconds. The time taken for the train is 24 seconds to pass the cyclist. Answer is option B. Question number 6. A passenger is traveling in a train moving at a speed of 54 kilometers per hour. He notices that a freight train moving in the opposite direction takes 12 seconds to completely pass him. If the freight train is 300 meters long, what is the speed of the freight train? So to find out the relative speed, we should have both the speeds. Here we have only the speed of the train in which the passenger is sitting. So let us assume the speed of the freight train is S. So let us find out the relative speed. So relative speed. So since the trains are moving in the opposite direction. So opposite direction means we have to add 54 plus S. S is the speed of the freight train. 54 kilometers per hour is the speed of the train in which the passenger is sitting. So here the time is given in 12 seconds. So we should convert this 54 into meters per second. 54, convert this into meters per second, multiply with 5 by 18. So that gives 18 3s 54, 3 5s 15. 15 meters per second. So speed of the train in which the passenger is sitting is 15 meters per second, and the speed of the freight train is S. And he notices that the freight train moving in the opposite direction takes 12 seconds to completely pass him. If the freight train is 300 meters long, so the distance to be covered is the length of the freight train. Distance to be covered to completely pass is the length of the freight train 300 meters. So for the train to completely cross the passenger, it should cover a distance of 300 meters, which is the length of the freight train. So distance to be covered is 300. Relative speed is 15 plus S. And the time taken is 12 seconds. 12 seconds is the time taken. So simplify this and find out the value of S. So by cross multiplication, 300 is equals to 12 into 15, 180 plus 12s. So 12s is equals to 300 minus 180, that is 120. S is equal to 120 by 12, that is 10 meters per second. The answers are given in, options are given in kilometers per hour. So we have to convert this into kilometers per hour. So how to convert? Multiply with 18 by 5. So by simplifying this, 5 2s. What is remaining? 2 8s 36. 36 kilometers per hour. This is the speed of the freight train. 36 kilometers per hour is the speed of the freight train. Answer is option B is the correct answer. Question number 7. Two express trains X and Y are moving in the same direction at speeds of 96 kilometers per hour and 78 kilometers per hour respectively. So length of train X is 180 meters while the length of the train Y is 240 meters. How much time will train X take to completely overtake train Y? Here both the trains are moving in the same direction. So when they are moving in the same direction, the relative speed is the difference. So what is the relative speed here? Relative speed is the difference of the speeds. Relative speed is the difference of the speeds. So what are the speeds? 78 as well as 96. 96 minus 78. That is 16 minus 8 is 8. 8 minus 7 1 is 8 minus 7 is 1. This is kilometers per hour. But here length of the train is given in meters. So we have to convert relative speed also into meters per second. Multiply with 5 by 18. By simplifying this, 18 ones. So this is 5 meters per second. This is the relative speed of the trains. So what are the lengths of the trains here? 180 and 240. So to cross the both the trains, both the lengths of the trains has to be crossed. Distance to be covered is lengths of both the trains. 180 plus 240. So lengths of both the trains have to be covered. So that is 4 plus 8, 12. 420 meters. This is the distance to be covered. Now time taken is, distance to be covered is 420. Relative speed is 5. So if you simplify, 5 8s 40 and 5 4s 20. 84 seconds. This is the time taken for the train X to completely overtake train Y. 84 seconds is the correct answer. Option D is the correct answer. Question number 7. Two trains of equal length are moving in opposite direction at the same speed. Each train is 150 meters long. If they completely cross each other in 15 seconds, what is the speed of each train? So lengths are also equal as well as speeds are also equal. So length of the train is 150 meters long. So both the trains are 150 meters long. So distance to be covered will be lengths, sum of the lengths of the trains. So distance to be covered is sum of the lengths of both the trains. 150 plus 150, which is 300 meters. Relative speed. Relative speed is, since the trains are moving in the opposite direction, sum of their speeds. So speeds are equal. So S plus S. 2S is the relative speed. Relative speed is S plus S, 2S. Now the time is 300 divided by 2S. So which is equal to 15 seconds. Which is equal to 15 seconds according to the question. Now simplify this and find the value of S. So 300 is equals to 30S by cross multiplication. So this is 30 10 times. So S is equals to 10 seconds. 10 meters per 10 seconds is the time taken. So speed of the each train we have to find out. So speed of the train is 10 meters per second. 10 meters per second. 10 meters per second. Answers are given in kilometers per hour. So we have to convert into kilometers per hour. Multiply this with 18 by 5. Simplify this 5 twos. So 2 8 is 36 kilometers per hour. So these are the speed. Speed of each train is 36 kilometers per hour. Option C is the correct answer. Question number 9. Two trains bound for Chennai leave Hyderabad at 7 am and 7:30 am respectively. The first train travels at 96 kilometers per hour while the second train travels at 120 kilometers per hour. At what distance from Hyderabad will the second train catch up the first train? The first train is starting at 7 am and the second train at 7:30 am. So that means first train is uh, ahead of 30 minutes of journey. So what is the speed of the first train? Speed of the first train. Speed of first train. First train travels at 96 kilometers per hour. 96 kilometers per hour. So it is 30 minutes ahead. What is the distance covered by this first train? Distance covered in 30 minutes. 30 minutes is half hour. So multiply this with half. Simplify 48. So 48 kilometers. So already first train has covered 48 kilometers ahead. Now second train also going in the same direction with a speed of 120 kilometers per hour. So what is the relative speed we have to find out here? Relative speed, since both of them are traveling in the same direction, we have to subtract. Speed of the second train 120, speed of the first train 96. The relative speed is 24 kilometers per hour. 24 kilometers per hour. This is the relative speed of the trains. So now to catch the first train, the second train has to cover a distance of 48 kilometers. So time taken is time taken to catch the first train is 48 kilometers, the distance to be covered. Relative speed is 24 kilometers per hour. So if you simplify 24 to 48, so it will take 2 hours. So it will take 2 hours for the second train to catch the first train. But our question is distance. At what distance from Hyderabad will the second train catch up the first train? What is the distance traveled by the second train in 2 hours? So in 1 hour it will travel 120 kilometers per hour. So distance in 2 hours. Distance in 2 hours is 120 multiplied by 2. 240 kilometers. So at 240 kilometers from Hyderabad, the second train will catch up the first train. Option A is the correct answer. Now let us see question number 10. A bus can travel 25% faster than a car. Both start simultaneously from city A and travel to city B, which is 90 kilometers away. During the journey, the bus stops for 18 minutes at a rest area. Yet both the bus and the car reach city B at the same time. What is the speed of the car? So we have a bus and a car here. Bus and a car. Bus can travel 25% faster than a car. So let us assume the car has 100. Speed of the car as 100. Then bus will be 125 because it is 25% faster. So now let us assume the ratio. Let us find out the ratio. Ratio of speeds. Ratio of speeds is 125 is to 100. So simplify this, 25 5s, 25 4s, which is equals to 5 is to 4. This is the ratio of speeds. Now, as usual, ratio of time. Ratio of time is the inverse ratio, 4 is to 5. Now, what is the difference here? Difference of timings. 5 minus 4 is 1. So 4 parts is speed of the time taken for the bus, and 5 parts is time taken for the by the car. So the difference is 1 part. 1 part is the difference between the timings of both bus and the car. So but according to the question, the time is 18 minutes. The time is 18 minutes. So this 1 part is equals to 18 minutes. 1 part is 18 minutes. Now we have to find out speed of the car. So to find out the speed of the car, we have to find out the time taken by the car. So the car is taking a time of 5 parts here. 5 parts we will find out here. That gives the time of the car. 5 parts is 18 into 5. 18 5s 90 minutes. 90 minutes is the time taken by the car. So we have to find out the speed of the car. So speed of the car is distance between A and B. What is the distance between A and B? According to the question, it is 90 kilometers. So speed is equals to distance by time, 90 kilometers, and the time is 90 minutes. So 90 minutes you have to convert into hours, divide this with 60. Now simplify 90 by 90 into 60. So this will get cancelled. What is remaining? 60. So 60 kilometers per hour. 60 kilometers per hour. This is the speed of the car. Speed of the car is 60 kilometers per hour. So here, instead of finding the 5 parts, so if you found out 4 parts, you will get the timing of the bus you will get, and then you can find out the speed of the bus also, 90 divided by whatever is the timing of the bus. That gives the speed of the bus. So C is the correct answer here. Option C is the correct answer. So these are the problems based on trains. So we have covered almost all the models in this problems on trains. So if you come across any more models, you can mention them in the comment box. So we'll cover them in the next sessions. So we'll meet in the next session with another topic. Thank you.